Now, when you're doing those mitigations, right? Let's say you're like, you're at the point where you say, hey, I'm ready to start shopping now, right? We did our risk assessment and it's time to figure out what we're gonna buy. I'm gonna tell a quick story. So I have another aerospace fastener company that's a customer. They came to me because they had realized that they have grinders at each of their CNC operator stations that they use for sharpening tooling. And I was a little surprised that they were using like high-speed steel tooling on some of these CNC machines. But so they have 70 grinders, and they realized that they needed anti-restart prevention. So they bought a commercially available UL-listed anti-restart device. And they were doing something kind of amazing, which everyone should do, but very few do, which is looking through and testing their safety equipment every month, right? And so in that testing, they realized that between 1 and 3 of these brand new devices were failing every month. So just a quick visualization of what that looks like. Every month, a couple more are no longer protected. And with this particular failure, there was no other evidence. Only in testing it did they realize that it had failed. It had failed in the closed position, meaning that just the tool worked normally, but if there had been a restart, it wouldn't have worked. And so that is terrifying. And that I started looking into, and like any good engineer, I took one apart and started kind of going through the things of like, why would that happen? And so first of all, I look at electrical ratings, right? And so one of the first steps always is seeing if like, is it technically gonna work? So, and in this one, I also looked for the test lab rating. So this one has, has a relay inside it, the primary switching part, right? Which is UL recognized, CSA and TUV recognized. The product itself was UL listed, okay? So couldn't be that. It's rated for the right voltage, that's fine. It's rated above the current of this motor. So a very well-meaning safety professional will say, this is a product that works, right? This looks like it would work with my machine. And if you look at the marketing for these products, they're covered in pictures of bandsaws and table saws and all that kind of stuff. But it doesn't work, and there's a reason why. Electrically, motors as a load are notoriously kind of difficult loads. They store energy in a magnetic field, and if any of you remember doing this little experiment on the right when you were a kid, I don't know if you remember, but just that little coil you made to make an electromagnet, every time you touch it to the battery, it sparks. Now in real life, every time you turn off a motor, it's also gonna spark. And so inside that relay, there will be an arc like that, which is basically a welding arc every time you break the connection of a motor. And if a relay is not designed to handle that, it won't. It'll destroy it, sometimes in a single operation. And so that is why things exist, to check that relays will be able to handle motor loads. But if we go back to that device, I said it was UL listed, so like, why does that work? And here's the catch. That device, and there's others like it, it's not the only one, is UL listed as a, quote, appliance control. So it was tested in a category that is meant for household appliances such as portable lights and audio video equipment, and actually specifically says not intended for controlling motor operated appliances. So this is going back to that kind of prescription drug example I gave earlier. Here is a product being clearly sold as a safety device for industrial equipment that isn't even recommended for a blender, right? So that blew my mind and made me very angry. And what it should be regulated under is what's called UL 508. And there's other standards now too that are coming out, but industrial control equipment is specifically tested to work with motors in an industrial environment. And so just as a quick comparison, the relay, the primary switching device, these two relays go into two products that both have a 15 amp rating, right? And this is to scale. So you can see how just like they're beefier, they're built to handle these loads. And so that's why that device was failing. And we're actually filing complaints with UL and all sorts of stuff. So hopefully that'll get better. But this is something we see actually quite often. And so the kind of moral of this is when you're looking at specifications, obviously you want to look at, is it listed by a test lab? Because that is an OSHA requirement. All products installed in a workplace that plug in need to be approved by basically an independent third party, which normally means a test lab. And you want to make sure that it's approved for that purpose, which is super important. So we've talked about a lot of things. We're kind of wrapping up now. We've talked about the e-stops, accidental restart, and braking. And so I want to give just kind of a this little graph where on the x-axis is cost, vertical axis is kind of features. So all the way down at the bottom here, if you're comfortable rewiring something or have people that can, you have a UL 508 listed switch that can prevent accidental restarts for $20, right? Takes someone 5 minutes to install it. That is low-hanging fruit. There's no reason for that not to be on every single machine in a workplace. Now, that doesn't cover all standards, but again, it's low-hanging fruit. We know that could prevent injuries. That should be everywhere. But if you're not comfortable kind of doing that, or people don't want to be modifying machines, you can go up a little bit and get some approved anti-restart devices. Notice that we're skipping the ones that destroy themselves. You can also, as I mentioned, do a foot switch, right? Which you'll have to integrate with a little bit of other controls, but in some cases can count as anti-restart and e-stop. You can also go up to one of those UL 508A control boxes. Again, we're in the maybe $400, $500 range now. And these are available from everybody. They're all over the internet. And they're totally legit. Nothing wrong with them. Some you wire yourself, some you literally just plug in. Go up a little more. Our product, as I mentioned, does the anti-restart, e-stop, and motor braking, and it's something you just plug into machinery. So if you're going that direction, it's, again, a way for you to get a lot of kind of safeguards with it not getting in your way at all. And then, of course, you can always build a custom control cabinet. These get pretty expensive, but as you move past kind of simpler machines, this is where you have to go, right? All these things are going to be for the machines that tend to have kind of an on-off or a little bit more straightforward, saws, conveyors, things like that. When you start having more automated systems, you definitely want to go into the deeper into the standards and do a custom control cabinet. But again, I say low-hanging fruit a lot, but just think about, if you think about every machine and every motor in a facility, how many of them are just simple things? A conveyor that's only used at Christmas, that's just in an on-off switch, right? Or a bandsaw, or a disc sander, or a lathe, or a mill. They're just motors and a switch, right? So you can protect a lot of those with these simpler things.